Hey guys, welcome back. Today we're going to be walking you through our Arduino circuit and our code for our backup sensor. So if you take a look here, this is our transmitter code. We just define our echo and trig pins for our ultrasonic sensors right down here. And then we send that as data in front distance, back distance, right distance, and left distance. All of that is put into the data packet and then sent out through our transmitter. Kind of down here, the last thing in the transmission is we have some serial prints just to see our values that we're reading from the ultrasonic. So down here you can see our front distance, back, right, and left.
And over here we have the code for the receiver. On the receiver we have two LCD screens. One reads the rear distance and the other reads the front distance. So how all this code works is at the top we define everything, set the pin numbers for each connection, and also initialize some variables, including some values that we may change later on. And the real code begins here, where if a transmission is available, it checks if the front or the rear distance, these two sections work the exact same, just one for front, one for rear. If the distance is less than 10, it displays a red light. If the distance is less than 50, it displays a green light. And if it's greater than 50, it displays a blue light. Additionally, we have this section that checks if either the front or the rear distance is less than 10. So if you're really close to something, it buzzes our active buzzer. And then here we have the left and the right, where if the distance on the left or the distance on the right is less than 15, it activates the respective LED as a blind spot indicator. And for the LCD screen, this whole section is for the LCD screen. We made a timer that has a delay of 500 milliseconds between prints. This is just to make it more visually appealing, because when the LCD screen is printing a statement every 20 milliseconds, it doesn't look that good. And all of this is pretty self-explanatory. And we also have it so that if the front or the rear distance, this code works the exact same for both of them, is greater than our distance threshold, which we currently have set to 150 centimeters, the LCD will just print far. Otherwise, it'll print the distance read by that sensor. And at the bottom here, we have a bunch of serial print statements. This is just so we can see the data that we're receiving from the transmitter at all times and helps us debug. Over to Charlie for the circuit.
All right, great. So we're gonna give you guys a quick demonstration of how it all works. So right here we have our front sensor and then our rear sensor. And right now you can see that the LCD is reading out the front distance as far and the light is blue to indicate such. When we have something in a medium distance, we'll start reading out our front distance like 26, 27. We can see as we move that'll update that every half second, and our light indicating that will be green. When we get very close, we will begin to turn red and the buzzer will go on. Very annoying, which we have tape over to mitigate. It does the exact same thing for the rear. When it's far, we're on blue. We put something in a medium range, we'll start to read out, and we get real close, it'll turn red and have a buzzer. So then we have our left and our right blind spot detectors. When we cover the left, you can see that the blind spot indicator turns on. And when we cover the right, the other blind spot indicator, the yellow light over there, turns on. Some things to note, we can also power this off a battery. Right now we have it plugged into the computer so that you can see the serial monitor, and this component right here we will hook up to the receiving end, and that will allow us to supply power from two batteries so that we're able to power both of these LCD screens. Other thing to note is we have our box for the receiver here. Both of these slots are for our two LCDs and they will be press fit in. We're not going to mess with the circuit right now, but the same for these holes for the lights, so that you can kind of see they'll just slot in like that, and then we'll have male to female wires within our circuit inside. The other thing to note is we have components here that will house the ultrasonic sensors. Those will be connected to the outside of the car. We would love to have those printed for you, but unfortunately Labriola ran out of filament. So that did not end up happening, but they will get printed very soon. A few things to add still. We're gonna keep one wireless transmitter and then one receiver. Initially, we were thinking about doing two transmitters, but the data for that got kind of hard to differentiate, so we decided to wire up all 4 ultrasonic sensors to the transmitter itself. Keep one unit. We're also thinking we might add an algorithm within our receiver code that'll kind of walk a user through how to parallel park, so that can just be displayed on one of the LCD screens, and then we'll move front and rear distance onto the same screen. So we'll say, for example, go forwards, go backwards, turn, whatnot. Yeah, so other than integrating our lights and LCDs into the housing and adding our battery, and then the housing for the ultrasonics, that's our design. Thanks for watching, guys.